So good morning, everyone. Welcome to Leicester and welcome to the 5th annual UK conference of the HPC-AI Advisory Council. I'm Mark Wilkinson. I'm Professor of Astrophysics here at Leicester and the Director of the DIRAC HPC facility. So on behalf of DIRAC and Leicester and the HPC Advisory Council, AI Advisory Council, it's great to have you all here. And looking forward to a very interesting 2 days of talks and discussions. So the overall theme of this conference is responsible computing for simulation and AI workloads. And when we were trying to come up with a theme, we wanted to find a word that would basically encompass everything so that we could discuss as many topics as possible. So in that context, responsible, we're taking responsible to mean sustainability, so that's environmental sustainability, software sustainability, financial sustainability, ethical responsibility, so that's whether that's around trusted research environments and data trust, responsibility in the context of AI models or any other ethical responsibility. Cost effectiveness, because we're those of us in the public sector that are using taxpayers' money to build big systems, we need to be doing that in the most cost effective way and delivering the most in terms of returns on those investment. And so I think there's a huge responsibility on all of us to make sure that that's what happens. So it's a very timely time to have some of these discussions, because we're in a year we've had the Future of Compute review published earlier in the year, and big investments in AI already announced, and planned investments in exascale. So there's a lot going on in the UK context, and I think there is a responsibility on us as the community of HPC and AI practitioners and providers to make sure that we're doing the best we can with whatever investment is available. So with that in mind, there are panel discussions. So we've got a lot of talks, obviously, around various points relating to these issues. And then we've got 4 panel discussions covering various aspects of this. So hardware, software, what we can learn from each other in terms of what the HPC and AI communities can learn from each other, what we can do and should be doing about sustainable computing, and also looking at data management and trust. And we also actually, I said I would say this, when we were discussing themes, we also had a panel discussion called "What should the HPC-AI Advisory Council change its name to?" Because on the basis that HPC is hardware and AI is a technique. And so it's actually, maybe it should be the Simulation and AI Advisory Council. And then we decided, well, it's the HPC-AI Advisory Council conference, so it's not in our remit to suggest they change their name. But if anybody wants to ask that as a question to the panel, you are allowed to. I thought I'd start the event with some acknowledgements, because not everybody will be here for the whole time, so I'll say thank yous again at the end. So Brian, who will be talking straight after me, is from the HPC-AI Advisory Council. These events wouldn't happen without him, so thank you very much, Brian, for all you've done already and will do over the next 2 days. Supported by Gabby, also from HPC-AI. Dan Olds, who's sitting here at the front, videoing everything. All the talks will be available online, unless you say something incriminating and you don't want to be put on YouTube, in which case you tell Dan, and he will keep a copy of the video, but he but for future reference, but he won't put it on YouTube. Lisa Brandt, who you've met already out at the registration desk, has done all the local organising and made sure that you all have food and somewhere to sleep. The programme committee I've listed there, so I'm very grateful to all of them for their input on the speakers and the overall programme and discussing the theme. I was on that programme committee, so I've included my name. It's not to thank myself, it's just that if there's credit, give it to those, the first 5 names. If there's blame, you come and talk to me or Brian. I may pass blame to Brian if appropriate. Yeah. And finally, there is Lisa. Could we have a round of applause for Lisa while she's there? Perfect. as if we planned it. And finally, just to thank in advance all the speakers and panelists and all of the audience for attending. Looking forward to some very interesting discussions. And with that, I'll hand over to Brian.
All right. Well, as Mark said, welcome. Thank you guys all for joining the new Scientific Computing and AI conference, where we say, look for the answer. If you need an answer, look to the sky. I don't know. I'm still working that one out. But yeah, thanks for the suggestion. It's a really hard name to pronounce, anyways. HPC-AI. But welcome. Thank you for coming. Great to have you guys. Sorry for the early morning start. I know we usually do this at like 10 a.m., but we have a lot of great sessions going on. And all this really is thanks to the sponsors. So Cornelis, Microsoft, Xscale, thank you so much for helping put this on. It really means a lot. We wouldn't be able to do this without you guys. I'm not going to go through the agenda. In terms of the council, I think a lot of you probably already know who we are and what we do. I mean, it's been 15 years of ongoing working with with scientists and universities and the national labs throughout the world. So we've been able to work together on a great number of activities, such as being able to put together with our cluster center, which has about 11 clusters, usually donated from some of the OEMs. We're able to get a lot of the newest material. We've run a huge amount of benchmarks on it. In fact, we ran 13 additional ones just in the past 6 months, which is pretty good in terms of our resources. But we pretty much captured a lot of the applications that are there in the scientific computing world today. I'm sure there's more that we're missing. We're constantly rerunning these applications as we get this new hardware, and we make this all publicly available so you can see what we're doing. We're also doing a lot in terms of student learning and development. A lot of that is with student cluster competition that we do with ISE each year. And we usually work with the APAC community to be able to help with some RDMA programming. And we put on a summer seminar series for a lot of the Stanford graduates. And like this conference, we have a whole bunch of other conferences that take place. So if you'd like to come to those, be in that area, great. If not, we'll continue to see you back here. And that's it. So let's move on. Did you want to introduce Emma?
Yep. So we're very pleased to have Emma Barnes give the opening keynote of the conference. So Emma's the head of research and faculty IT at the University of York. She's going to talk about sustainable research IT, and I notice she's a background in particle physics, so that's obviously
degree in astrophysics. So
DIRAC, sorry. So thank you, Emma.
Just currently struggling with this. Right, thanks everyone for letting me join today and give this talk. I am going to talk about sustainable research IT and some of the steps that we've been doing at the University of York to make our compute more sustainable going forwards. So thanks for the introduction. So York's quite a small team when it comes to research IT. We have about equivalent of 10 FTE, and most of those people are actually RSEs. So from the infrastructure point of view, we're quite small, and that will feed into some of the choices and decisions we've made during the last few years. We're only about 5 years old, 6 years old in terms of what we're doing, but we are trying to sort of do things our own way and hopefully try and sort of, I don't know, give people different ways and different ideas and some of the choices they can make. So I do like a talking slide, if you can get one in. But I am actually going to talk about the sort of journey that we've had over the last few years and what essentially we have done as a university. So when I started at York Uni, I was kind of a half sysadmin and a half HPC specialist, research IT. They didn't really know, but something to do with that. And we had a whole bunch of departments doing sort of different things, particularly in the research IT and HPC space. And there was a lot of work initially just to try and consolidate some of that hardware. So we had lots of clusters and cupboards. We had clusters that were 10 years old. Postdocs were kind of looking after them if they knew what we're doing. I mean, that's how I started out as a postdoc, handed a cluster, and then I had to learn how to look after it. So I think this is probably familiar to a lot of people potentially in this room. What we wanted to do was try and sort of provide a better service in this area. And so we spent a long time sort of trying to consolidate some of this kit, at least either decommission where we can or consolidate where we can. So we started off with a cluster called YARC. It was 3,000 cores. It was a mixture of old kit and new kit. I call it a bit of a Frankenstein, but it actually, considering we had nothing at the time, it did the sort of community there at York a good service. It did well. So as part of this process, we wanted to also teach people how to use the cluster. So we started to introduce courses, things like Introduction to Python, Introduction to Linux. So I'm very big on sort of accessibility in terms of getting people to be able to use these facilities. I have a science background. We have a tendency to need to have used sort of HPC and HPC environments, but I actually want to move that further. I want everyone to be involved if they're interested in using this and apply it to their research. Eventually time went on, we started to get a lot of interest, a lot of use, and the university actually invested £2.5 million in our first sort of proper cluster. And since we're from York, we called it Viking. It's easy to spell. We had things like Eckbert and all sorts of stuff, which, yeah, great words and great names, but spelling's not my strongest suit. So anyway, we built this, and it's been really, really successful. We did a few other things with a few other systems at the university. So we wanted to simplify some of the kind of larger Linux desktops. So the idea was a person might be using a Windows sort of laptop or desktop or something, but they needed to kind of move to HPC. So we wanted to make that path as easy as possible. We use EasyBuild to deploy our applications and modules. So not only do we have that on our cluster, on the Viking cluster, we also have that on some of our kind of bigger desktops, and we also have it on our classroom PCs as well, on our Linux classroom PCs. So that means when a person moves to HPC environment, they only have to learn about schedulers and writing job scripts. We already know about modules and that sort of side of things. So it's trying to sort of reduce that step where we're trying to get people to move to HPC, essentially. So funny enough, we had our official Viking launch event on Valentine's Day in 2019, so that was fun. So it's been 5 years since we had this. It was really successful. We had a lot of users using it. We did a lot of monitoring in terms of outputs, trying to get people to tag us in a research output and tag us in a grant and things like that, so we can at least go back and say, look, it's worked. Can we have some more money, please, to do it again? And we also had, majority of people were sort of sciences, although bioinformatics at the time was kind of growing quite significantly in the university, and the sort of scientific, research outputs, actually, biology beat everyone else in that area for the first time in the last year. So it's been a really good tool. But I think one of the positives is we've been able to move people away from these really inefficient sort of clusters in cupboards. So that's been great. Now, so as I said, it's 5 years old and we're at the current era. And things have changed. So electricity has become expensive. Our budget has not increased. So we've got a capital budget that looks the same. And with a good capital budget, you get more nodes, more GPUs, more CPUs, faster storage, whatever you want. And it will be bigger, but we can't actually power it because we don't have an increase in that side of the funding, or not easily anyway. We can't host on campus. So one thing which is different with York Uni is back 5 years ago, we didn't actually have enough power to host a HPC facility. So we already had to move that to another data center in Leeds. So we're kind of used to the idea of not necessarily hosting on site. Leeds is not that far away, but it's still not in walking distance if you need to do anything. We also struggled, so when I first sort of started looking into this and looking at the refresh, we struggled with sort of trying to get in touch with UK data centres in terms of hosting. I know HPC is a bit of a pain. I know we like to produce a lot of heat, we just consume lots of electricity, and the type of power we want in our racks can be quite large, so sometimes we might have to take up a lot of space or have, the density is not great, whatever. We are a little bit problematic. But on the other hand, this type of work is really important, and it's becoming more and more embedded in the research at the university. And we looked also into cloud. I know some universities have started to shift some of their workloads, HPC workloads, to cloud, but for what we're doing and the amount of work we do in our facility, it was just not a viable option financially. So it kind of left us with a bit of a conundrum. And I think this is something which is starting to impact a lot of people. And it's not just sort of electricity cost, which is obviously a main driver in a university, but it's also the environmental sort of impact of HPC as well. CPUs and GPUs are just becoming more power hungry as they grow with performance. And this is extremely problematic because we're struggling to find appropriate data centers to actually power what we want, to cool what we want, and the different sort of cooling options to be available. So, you can gain efficiencies by good and different ways of cooling, but not all data centers have that, and it really does cause a problem. Another big problem is the electricity prices. This essentially would mean we would end up with a smaller cluster if we based it on the current pricing. So we were kind of weighing up all these. And then you sort of start to look at the full environmental impact of what we're doing. We have environmental research happening on Viking, and it will be happening on our new system. We have to be a bit more responsible about what we're doing and how we're doing it. The University of York has an aim to become net zero by 2030. It's something which we're pushing for. Other universities, other companies are also doing the same thing. I've put the different scopes. Scope 1 is when it's a direct, so you might have vehicles which you're driving and you're using petrol to run those vehicles, and that'll be considered scope 1. And you have scope 2 and 3 which are indirect, so you're looking at maybe where your electricity is coming from to power your university or company or things like that, and how was things built and what's the carbon footprint of that. This is becoming a lot more important in terms of how people are running their businesses and also within universities. And I think taking all this into account, I actually think there's a real risk to research that relies on compute. If you're already a facility which is maybe hosting a regional or national facility, you probably are already thinking about your data centers. You're probably already thinking about how you're going to be cooling and doing it in the most sort of sustainable way. But for people in universities like the University of York, we don't have that option. And I've spoken to other institutions which are also struggling from the same thing. A lot of universities are trying to get rid of their data centres, whether it's because they're based in London and real estate's very expensive, or they don't want to invest sort of X number of hundreds of thousands of pounds to improve their air cooling or whatever they have. So I'm worried there's going to be a situation where we're not feeding in academics, research into the lower tier sort of facilities, and the research in these places is actually going to take a bit of a hit because we don't have the compute available for them. So this is where my concern comes from. Sorry, some of my slides are a bit funny because I've had to PDF them, but that's fine. Anyway, so what can we do? Well, there are different options. I've mentioned cloud. I'll talk a bit more on cloud in a bit. Obviously working with vendors, hardware vendors, try to get them to see what our issues are. I know they're looking at different cooling options to sort of increase efficiencies and reduce sort of power usage, write more efficient code. I think that's important, and work with and lobby the government. At the moment, I was somewhat dissatisfied about the options that were available at the time in terms of hosting. I'm sure they're going to improve, but the people I talked to, I just didn't, we just didn't really, well, in one particular place, we sent a person who didn't even know much about the company when we started to talk to them, which was really not good. So I'm going to quickly talk about cloud. Cloud does have a lot of, so the different cloud vendors, I think people tend to go for Azure, Google, AWS, I know there's Oracle and other sort of public cloud as well. They do have a lot of great sustainability initiatives, and I think one of the things is they can do things on scale, unlike what myself as a university can do. It's also really flexible, so I've always liked that in the sense that I just want to test the new GPU, I just want to test FPGAs, I want to just try this. We don't have to then buy that, and I think that's really good because you don't end up with a bunch of kit which is underused and underutilised and things like that. It can be expensive, so I think if you're for something that we were doing with Viking, it would have been just too expensive at the moment. And also the barrier to entry can be a bit steep. So I know there's a lot of ways and new technologies coming online, new services coming online in the cloud space, but there's still a little bit of a fear for people, and they're still a bit confused in terms of accessing these new technologies. We do use cloud though at the university, and one thing we've decided to go for is kind of point solutions. So we're looking at, we're using something called Azure Virtual Desktop, and this is for the generic desktop environment, but what I want to do is provide a facility for Windows users where it requires just a few more cores, a bit more RAM. They don't necessarily need a HPC facility, but they need something for a few days, a few hours, which is just a little bit more than their desktop. And what this means is we can get rid of their desktop, which we've had for 15 years, which they can run their stuff on for 2 days. We can move all that to the cloud. We also use an Azure Labs for teaching. We've deployed it in computer science in the University of York. It's been really, really, really good. We can schedule it, people can use it as much as they need it, and then we can turn it off. And it also means that students could get access to GPUs and things like that, which we couldn't really, buy for a particular course. So that's been really good and very well received. We've also done sort of projects in the cloud. So we work with a company called Alces, who run our hardware for Viking. And we worked with them and a psychology professor on looking at mammograms and trying to understand how a consultant can see a picture of mammograms and know that there is a problem in this one and not that one, and what are the processes that are going on there. So we were actually nominated for an award for that particular thing. At the time we only had 8 V100 GPUs, so it was nice to be able to go into the cloud and just get as many GPUs as we want. So that was great. And Azure actually, Microsoft Azure actually gave us some funding as part of that, which was really, really good. We're also currently working on putting our trusted research environment in the cloud. We do have one physically located on campus at the moment. With this being in the cloud, we're hoping to expand into other areas and get other people to use these facilities, which would find difficult to do just because of the restrictions on trusted research environments. They need ISO certification, and there's just a lot of work to do with that. So if we can do something cloud-based, it just gives us a bit more flexibility. And CloudSpan is another teaching project that I was part of as well, doing biology, which I've never done biology since I was 16, but I was able to at least assist in that area, so that was good. And also various apps and things. So cloud has been great as point solutions for these sorts of different things. But in terms of sustainable compute, I think one of the big things that we need to utilise as research software engineers, we've been growing the team at York. I think writing more efficient code is really important, better code. Got the Software Sustainability Institute, who provide a lot of sort of guidance and support and help in this area. It's not just about writing better, sort of efficient code, but also code that is understandable. So it's easy to share that, and then a person can go and look at it and say, actually, I can tweak this. I can see the wood from the trees. So it's the whole thing that's encompassing it. One thing we want to do as part of our sustainability program in York is to hire RSEs who are just focused on that bit. My RSEs tend to be bought out in specific projects and things like that, but focusing just on making code more efficient is something we really want to dedicate into that. And in terms of the infrastructure, we also want to kind of tell users how much carbon did that cost your calculation? How efficient was your calculation? Could you do this better? And again, have more of a sort of user awareness of what they're doing, and then if they need support, we can come in and help. Okay, let's have a look at what you're doing. Let's try to make it more efficient. Why are you only using 0.5% of the total RAM at this particular moment? Let's change this up. And just sort of working, things like schedulers, for example, try to find the most efficient ways to pack our workloads on our clusters. There's things like backfilling options and stuff like that, so we don't have things which are just sitting idle. Everything's in use and is in use for a purpose. There's also some other things I've mentioned on here: CPU frequency, Archer 2. The group in Edinburgh have done a lot of work on sort of looking at performance versus reducing sort of CPU frequency, and there's also sort of different cooling options. Now, the big thing we've been focusing on is data center location, and one thing that's a little bit depressing is the fact that UK data centers are not great in terms of their sustainability credentials. The one in our data center at the universities, about 2 PUE, which is quite bad. So one of the ideas for Viking 2 is, can we host it somewhere cold? Because that would make sense. And we decided to put this to Alces, who are our partner in terms of Viking 1 and Viking 2. And they looked at sort of some options, and we wanted to, first of all, reduce the electricity bill, but also look at somewhere which is really sustainable and really sort of takes this piece seriously. And what we found was a place called Eco Data Centre, and literally about a year ago, we went over to Sweden to have a look at the data centre and to see what it's like. So it's about there on the map. So the benefits of doing this: cost is a big one. Essentially, we're paying what we paid in 2018. That's great. We can potentially get a HPC facility which is at least the same size, if not bigger now. We also don't have to pay rack rental costs, so I'm seeing my cores increasing and my GPUs increasing in terms of what I can provide. And it's also a fixed price for 5 years, which our finance at the University of York love, which is good. In terms of this particular data centre, all the electricity is from renewable sources, so it's hydro and wind. It's better than net zero. All the data centres are constructed with wood. Everyone thinks, oh, it's not going to burn, but actually, supposedly wood fires are a lot easier to deal with than concrete and things like that, because it's just predictable. So I'm not a fire expert, but that is what I've been told. And all the heat that is produced in this data centre is actually reused. So there's a factory next door to the data centre that uses as a sawdust mill. It gets all the heat from the data centre and then uses that to dry all the sawdust. And this sawdust is then turned into wood pellets and then used for district heating and things like that. One nice thing as well, you get comprehensive reporting. We have to start reporting more on what we're doing. And this is great. I've struggled in the past to get comprehensive reporting in terms of the sort of sustainability side of things relating to HPC. We can make estimates, we can try, but this is really good. And this is something you get. And it's also designed for HPC, which I was very excited about. They want our heat, they want the density, they have all sorts of different cooling options, and coming in and saying, I want to put, multiple racks of CPUs and GPUs. Well, their response was, okay, not ooh, which I had in the past. So essentially we've moved all our batch processing to Sweden. We had a bunch of GPUs, a small GPU cluster in our data center for a short time, and it caused no end of issues in terms of cooling and heating and things like that, so they've also been moved. And the way we are going is to use the future of our compute is going to be either Sweden for batch processing or cloud. And we're going to try and focus on doing that. Also, security-wise, we've got all the credentials. I think the Swedish Secret Service also has stuff in there, so if it's good enough for them, it's good enough for me. I think H&M's in there and some banks as well, so it's great from that perspective. And one nice thing is we're going to be able to grow. I think we've struggled a bit in space in other data centers. So, you know, if someone does come in with a large grant and say they want extra CPUs or GPUs, we're actually going to be able to do that. So challenges and gotchas. It wasn't easy, as you can imagine. This one was really difficult to navigate, and I know far too much about Swedish and UK VAT and tax law now and import law than I ever wanted to know in my life. I prefer to stick to Linux, please. So there's a little bit of confusion if you're part of higher ed. We're sort of a charity, but we're not quite a charity, and blah, 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 blah. So we ended up having to pay UK VAT, but then Sweden said we also have to pay Swedish VAT. We couldn't zero rate our purchase, but double taxation doesn't make sense. We should be able to not have to pay tax twice. It's insane. Anyway, we did eventually find a solution. So if you're thinking of doing that, take that, because it might save you some money in talking to people. There is a way to get around it. This is one particular method of doing what we've done. We were somewhat trying to do something different, and there are probably other ways to do this as well. You could potentially just send your kit direct to the country where you're wanting to host. But we found this way and it worked, but it was a stressful couple of months trying to sort this out. I'm not going to lie. So I think one word of advice, if you're thinking of doing this sort of thing, talk to your tax people, talk to your procurement people, and talk to your finance people first before you even do anything about hardware or anything, just to at least so they are aware. I was probably a little late in talking to them about that. It did mean we have to pay both lots up front, so it's a lot of money when you're talking about clusters and £2.5 million budget, so university wasn't that happy with me. But we are getting it back. Customs can be a nightmare, but we actually paid for a service to do that, so they were able to navigate that. I'm not going to pretend I know that side of things, I don't. So use the experts when you need to. And it's still, and after all this sort of trouble we went to and things like that, it's still going to be cheaper than what hosting in the UK, just based on the current pricing, so it still works out. Network connectivity, we've actually ended up using a commercial provider early on. We've gone for a 2 gig link. We were able to, because we'd already had our facility off-site in a data center in Leeds, we actually knew what the data usage was. We had a 10 gig link before, we never used it. So we went for just 2 gig, but it is burstable. So I suspect it'll be very burstable when it first turns on, because everyone will want to move their data straight away. It took a long time to arrange. Procurement weren't very happy with the contract. I think they're a massive company who we've gone with, so there's been a lot of negotiations. I've spent a lot of time talking to procurement, legal, and tax people, which I'd never expected, but there you go. It's been an interesting thing to learn. I think one thing is pioneering is hard. It's been a lot of work to get to this point, but I think what we've done is sort of good for York in the sense that we are able to actually build a facility which is going to be really good for our users. We would not have been able to do that with the options that we had available to us at the moment. And here's some sort of points I would suggest, to look in. Our sector is quite risk averse, so I'm really pleased we convinced them to go down this route. Not really sure how, but we did. And yeah, there's just going to be a lot of talking, but hopefully, since we're happy to talk about the process, if anyone wants to go through the process, we can hopefully help smooth it for other people. And then those are the wood pellets that the factory and the data center Sweden produces. So I guess to tie it all up, I guess my biggest concern is that we're going to end up with these kind of situations where people are not going to be able to do the research they need to do, or end up getting access to the compute in some of these sort of smaller institutions. Oh, well, I know York's quite a big institution, but we don't host the kind of tier 2, tier 1 facility, so we don't necessarily have the infrastructure in place right now to be able to host these environments. I do think we need to get better at the sustainability piece. A lot of the research we do is for the public good. It is important, but I think we can become a bit smarter in how we go about either running our code, making it more efficient, or in our particular situation, we decided to go for a more sort of sustainable commercial data center as well. And I guess the big takeaway for me is, unless we decide to change, and I think it's a community effort, then there are going to be gaps, and we're not going to start feeding through these people to the bigger facilities as well. So I think it's something which is starting to happen now, and will proceed to happen even more so in the future as well. Now, in terms of Viking 2, you might see me ferociously typing in the background. We are hoping to go live next week. We've had access to the facility for about a week and a half. We've been building our 4,000 applications with Easy Build. Thank you, Easy Build. I used to have to do that manually myself. We're looking to maybe, if more people become involved, to use JISC and the Sunnet connection instead of having to go through a private network connection. And we're potentially looking at it for other DC data center uses as well, to try and reduce our footprint on campus. Not everything can go there, but it's something we can consider anyway. And he's a contact for me, but also Richard Fuller. So it's myself and Richard Fuller who've been working on this for the past year and a half. So shout out to Richard as well. So thank you.